If you're in an enterprise and you knock out a random file, some guy on the phone is like, why is my doc file in quarantine? I don't know what you're talking about. I literally just wrote it. Why is it in quarantine? And, the admin's like, yeah, it's fine. I'll look into it. Cool. No big deal. If we misclassify something, we just took down 1 million sites.
Yeah.
Just one shot. You just took down the email communication for what, 6, 100? It's a horrible blast radius for any kind of false positive.
Yeah.
And so we really, really spend time, effort, money, making sure that doesn't happen.
Rob Seger of Monarchs, Chief Technology Officer at Monarchs. Welcome to the podcast, the MailChannels podcast.
Thank you.
You started your career working at the National Security Administration, commonly known as the NSA, a mysterious organization that has powered many intriguing movies with varying degrees of accuracy, I'm sure. Now, most people, if not all people who worked at the NSA, unless they're headed to jail, aren't normally able to talk about specifically what they did when they were there. But I was wondering if you could talk about what you learned, like the skills that you learned that have been valuable in the rest of your career that you gained while you were working at NSA as a young person.
So NSA was a fantastic place to start my career because I really did learn just a ton of very useful things, both good and bad, as you would expect. The federal government's not perfect. But a couple of the highlights, I worked in an office called protocol exploitation. You can take a wild guess what that is. Anybody can guess. That's cool. I will neither confirm nor deny. But one of the things about that is the problem space is so large. It's almost infinite in that. How do you tackle a problem that's that large? How do you divide it into, chunks that people can work on simultaneously, that you can make sense of this ever evolving and incredibly rapidly iterating area? Like, how do you manage something like that? And that turned out to be fundamental to cybersecurity. The problem space is almost infinite. It's rapidly evolving. It's just the same kind of skills to split the problem apart, to be able to parallelize it. I also learned a lot about management. It was more of the here's what not to do. But my direct manager was actually really, really good at his job. He understood how to motivate quirky humans incredibly well and get them directed at one thing. And so I've kind of stolen a lot of his techniques, thought processes, so on and so forth, and then tried to avoid everything his boss does.
I see. So the organization gave you some lessons and some anti-lessons.
A little bit.
Very, very good. Very good. Now, obviously, NSA is kind of unmatched in its scale globally.
It's pretty big.
I don't think a lot of people can appreciate just how big it is and just what all those people do. But when information emerges about some of the exploits that NSA has been involved with, it is mind-boggling what's been accomplished.
Yeah.
After leaving NSA, you went to work in private industry, and you've worked at a series of startups. You've worked at a big company, Palo Alto Networks, along the way.
Yeah.
What did you learn about that would help build defensive computer security technology from having had the experience of working on the offensive side, which is what I assume NSA is mostly working on? You don't have to confirm that, but
no, it was interestingly, it was actually the middle piece between NSA and when I went to work. I worked in the federal government still, but specifically at the FDA, the Food and Drug Administration. They brought me in because they wanted to completely redesign their basically their network so they could secure it. One of the other things that I had learned at the NSA was kind of a systems of systems ability to think. Protocols force that because it's not a protocol in isolation, it's a protocol being leveraged everywhere. And so I really had a good understanding of network architecture, just instinctual, was really good. And that's why I got hired to help redesign. What I kind of fell into and learned is I thought that I was a genius, that I was the greatest thing to cybersecurity in the entire world. I always won. I'm an attacker. I always won. And I realized when I got to the FDA and I really started designing things and trying to work systems and think things out, how do you secure this, so on and so forth, that I'm not really a genius. I was playing on the easy side. Attackers always win because there's an unlimited number of ways you can tackle the problem. Defenders always lose eventually. And so really what you're trying to do is mitigate the blast radius. When you do lose, how much does it hurt? When you do lose, what exactly are the consequences? And so the defensive side has an entire different problem space. And being on the harder side of things, being on the side where you've got an entire different economic model, all of that was very interesting, very exciting. And so I met up with a good friend, Raj Shah, and we spoke about how can we combine all of that to create a novel thing. And that was my startup career. It just kicked off from there.
Wow, fascinating. And like the timing of your startup career really overlaps with a lot of international events that were bringing a lot of public attention to the security realm, like the Edward Snowden revelations in 2011. That overlaps with the timeline of when you were getting out there with startups and getting acquired by Palo Alto Networks and whatnot. What were the sort of pivotal moments along the way in between, working for the FDA to harden their defenses and where you're sitting right now as the CTO of Monarchs?
So the economics behind selling in as a defensive solution were really enlightening. Being able to convince someone that there was a reason to invest in defense, really enlightening. Now, you mentioned Edward Snowden. Incidentally, not a fan, but him coming out with that was actually very helpful for all cybersecurity vendors because it gave something concrete to be able to point at and essentially say, you don't want that to happen to you. You should probably invest in preventing it. And it's not exactly the same as insider threat versus, we're protecting from external and all kinds of subtle caveats there that nobody recognized at the time. But it was actually very important, very useful. I also learned about the economics of venture capitalism. And that was pretty revolutionary in terms of just understanding the world. Our acquisition into a big company was also educational in that a lot of the negatives from the government aren't because of the federal government, they're because of size. I didn't really know that until I had size. So I ended up back out into the startup world
Right,
pretty
right. Yeah.
quickly.
That's very, very interesting. I've never worked for a really large organization. I've always stayed in small organizations, so I just don't know I don't know what it looks like. Let's move on to Monarchs. Monarchs, we all know monarch butterflies. I presume the word monarchs has something to do with that. Monarchs is based in Utah, and I know that Monarchs provides security to web hosting infrastructure.
Yeah.
Can you speak a bit more to let the audience know, like, what is it that Monarchs actually does? What I'm sure a lot of people listening have heard of Monarchs, but what is it that you actually do?
So if you think of traditional cybersecurity, basically everything I've been doing up until that point, you're effectively building walls and defenses, so on and so forth, against the attacker. And the attacker is this nebulous thing, could be coming from anywhere. It's horrible. It's scary. Nobody is really out there trying to be where the attacks start. The kill chains start in the cloud. They start in hosting provider infrastructure. And so amusingly, I actually thought that was a solved problem prior to joining Monarchs. I think most people in cybersecurity do, and it's very much not. But going out there into the woods, hunting it is absolutely incredible very, very interesting, completely different. But I would argue at least as, if not more important, because all of the attacks that you see, they originate in the cloud somewhere. And that's all hosting providers. There's no exception there. And so the mission for us is to clean up the internet effectively. In an ideal world, it's impossible, but in an ideal world, you wouldn't need a SOC. You wouldn't need enterprise security, because we would have stopped the entire thing at the internet effectively. That just would no longer exist. So specifically, like if you were to try our product today, what would you do? We encourage people to install it on shared servers, because what you'll find is that 1 in 3 of your users are popped.
Wow.
They've got malware, they've got phishing kits, they've got miners, they've got, who knows? There's all kinds of fun stuff they might have, but you'll find just absolutely ridiculous amounts of malware on your server, to the point where when you're selling into an enterprise, if you can get the scissor to install your product, you're like, okay, one piece of malware, just anything,
Yeah.
one
Just
piece.
find me something somewhere.
Boom, sold. The whole, that is the end of your sale. Monarchs, we roll in there, we get on test boxes, we get installed, and it's like, we found like 1.5 million pieces of malware on your systems. The numbers, just humans don't get numbers like that. It glazes over, and they're like, well, I mean, cool, explain to me why I care, kind of a thing. And that's a wild, wild difference. But in any event, we encourage people to install it. We find all of this malware. We come back and we say, hey, this shouldn't be running on the internet. We would love to take care of that for you. And so our bread and butter, what we do better than anybody else in the world, is identify and clean the malware that exists in hosting provider servers. We have a lot of other cool things that we do in addition to that, but that is the core. That's the one you're going to see immediately. And arguably the most impactful from the perspective of the rest of the world.
You know what I find interesting? We're working in a similar area, right? So the hosting servers get compromised, and then they send out phishing emails, and we see the phishing emails. So we're kind of downstream of the forest, if you will, like the river flows out of the forest with all the garbage in it. And what's always struck me is to think about the enormous value that we are providing by cleaning that up to a large extent. The number of attacks that are prevented by mail channels every month is in the millions. And when I think about it, how many victims are we stopping from being victimized every month?
And yet they don't know it.
Right. And you hear about cybersecurity, being worth billions a year, and the direct damages to the economy being in the billions. I'm not getting paid billions over here.
Nor are we.
I've always been frustrated by that. Like, it feels like the market is broken because all the money goes to the defensive companies on the receiving end of this stuff, and barely any of it trickles up to the companies that are that are trying to prevent it. And the hosting providers are sort of like innocent victims. Sometimes they're co-conspirators, but mostly they're innocent victims. Just because of the nature of what they offer. And they don't have huge budgets to invest in this technology.
Nor actually huge incentives, arguably. It's one of the tensions there. It's like, well, okay, so there's 1 million pieces of malware on my box, and they're sending, 1 billion spam emails, maybe impacting, a little bit of reputation, but nobody seems to care.
Yeah.
So why should I care?
Yeah, totally.
That's rough, but it's true.
Yeah. I get a few IPs blocked. Most of the impact is on my customers' domains, but
they're not leaving in droves.
Yeah, it's interesting. I've often, like, for years, I've been waiting for some government to take the issue seriously and roll out some legislation that actually starts to make providers do something about this problem. Haven't seen it yet. Haven't seen any accountability.
This, and please correct me if you feel differently, but I feel like the product and service we provide should be considered a utility. This should be something that a government is essentially like, this is for the good of the entire world, or at least the good of our entire country or whatever. Go forth and install it everywhere, and we'll figure out how you get paid on the back end. But this is just frankly good for everybody on the planet. Go and do it. And I really think that if we could explain it to the right people, what was happening, that there's a really good case for that. To your point, millions of victims, they don't have any idea that it happened. It was completely prevented. The number of pieces of phishing kits, let's just stick with phishing, that we clean up every day, insane. You may not be on those servers. The emails may have gone out pointing at these. When they land, it's a 404. I don't know what this is. Cool, they're broken. Like, just that little slice is so impactful. And there's so much more that could be done. But economic incentives of a free market, it's kind of weird. It doesn't line up very well in those two space.
Yeah, yeah, it's true. And it's also a very international market, right? The hosts are located all over the world. The
Yeah.
bad guys don't care where their stuff is hosted. They'll target everybody all the time.
And they do.
And they'll go to the lowest common denominator, right? Like the provider that's got the worst security or the biggest footprint that's the most easily attacked is exactly where they'll go.
Or the best free plan.
Or the best free, right? Exactly, the best free plan. Yeah, we're constantly amazed at what we see. So digging into the tech a little bit at Monarchs, obviously, PHP is the dominant operating environment for web hosting still. WordPress runs on PHP, and so do many other things. And there are these ancient platforms like cPanel and Plesk. What is the model that you bring to the hosting platform that allows you to clean up the malware on that platform? How does Monarchs actually hook into these services to do its job?
So we have our what we would consider a standard kind of deployment for anti-malware. It's just a service running in the background as a daemon that goes through and does everything you would imagine with the file system. It also manages processes, some other stuff that are ultimately really important, but we don't need to dive into. The other side really is PHP, though. While there's a whole slew of different plugins and ecosystems and things that are vulnerable for a whole bunch of different reasons, the complexity of the problem is because of dynamic languages, specifically PHP. You can do horrifically shady things with PHP code, and it will still execute. And it makes it so that your standard regex, like, just don't let anything execute, never allow exec. Totally useless. It doesn't work at all. You have to innovate beyond that because it's so trivial to undermine. And so we have to be inside the PHP engine as a component of that. Our Zend extension runs in there. But we also have to have an entirely different analysis stack in order to be able to deal with it. And so those are necessary evils. They're also really cool. It's a lot of fun to work on that kind of thing.
Yeah. So you literally hook right into the execution environment. You're not relying on regular expressions. You're literally looking at like what bytecodes are executing here on the machine. What are the side effects that the code is causing to happen? That sort of thing.
Yeah. Now, don't get me wrong. We don't limit ourselves. If there's a really easy regex rule that they're going to do it, I mean, don't be dumb.
Yeah.
But yeah, the being inside of the engine, and we're loaded as a shared library, which is different than loaded as a plugin. As a plugin, you're running even playing field with the attacker. They can unhook your stuff just like you can unhook their stuff, and it's just kind of an arms race there. We are actually modifying the PHP executable as a shared library that gets loaded. And so we are literally redefining what PHP, the language, is on these servers. And we're doing it to effectively harden not only the language, but also a lot of the vulnerabilities that exists in the ecosystem. And we cannot be unloaded. It's not possible. We exist 100% of the time. And we do dynamic analysis. We look at and say, okay, you want to write a file. That's all great. I love that you're writing a file. What is that file? And we're able to look at it and say, hi, this is not getting written to disk. Or I want to log in. It's like, oh, that's fantastic. We want you to log in too. Here you go. Oh, this is the 500th time that you've tried to log in. Sorry, no more. Obviously, thresholds are different, but
Yeah, yeah.
in any event, you have that level of visibility. My favorite is the SQL injection. You can do SQL injection protection at the network layer for sure and in a WAF, but you can also obfuscate at that layer pretty easily. When you get into the PHP engine where we are, it has to actually execute. It has to actually hit the database with a clear text. What is the SQL string that is going to be executed in the database? Because there's no other way to get it
Right,
executed in the database.
right.
And so you can't hide your SQL injection at that point. It's just a naked boom. There you go. And so it's a cool place to be in the kill chain.
Yeah,
And I mean, it comes with challenges, of course, but it's a good place to be. All of our like static analysis or malware analysis or cleaning or all of that kind of thing actually doesn't happen on the customer's box. We do that in our cloud so that we can leverage as many resources as we want. Because for some of these things, like I said, simple regex, bingo bango, doesn't matter. It's gone. There are some really amusing, really old pieces of malware that constantly exist because they work. Not the system we see, but it's very easy to detect them as well. Some of this stuff is so incredibly ridiculously obfuscated that you need to burn a lot of resources in order to correctly identify it and not knock out a whole bunch of good stuff, which you cannot afford to do.
right.
Um, and interesting, that's another, forgive me for going on a side tangent here, is another real challenge with the hosting space. If you're in an enterprise and you knock out a random file, you get some guy on the phone that's like, why is my doc file in quarantine? I don't know what you're talking about. I literally just wrote it. Why is it in quarantine? And, the admin's like, yeah, it's fine. I'll look into it. Cool, cool, cool. No big deal. If we, and you as well, I mean, you have the same problem. If we misclassify something, we just took down 1 million sites. Just
Yeah,
one shot. You just took down the email communication for what, 100? It's a horrible blast radius for any kind of false positive. And
yeah.
so we really, really spend time, effort, money, making sure that doesn't happen, or at least as best you can. In cybersecurity, you can never be perfect, but we really do fight to be right there. But hosting providers sell the compute and the
Right.
RAM and the
What are you gonna
everything.
do?
And so burning their stuff is unacceptable. So we do it in the cloud.
So you must do a lot of really fancy machine learning stuff in the background to do what you do. I mean, to operate. I know from the email side, right? Uh, our constraint is that we have to be able to deal with something thrown at us that could contain any content that we've never seen before. And yet, that email sender wants to get a response pretty quickly as to whether their message has been received or not. And legitimate users want their stuff to get delivered through to the other side within seconds. Otherwise, they start complaining. We can't sit there all day. We can't take messages off to the side and have somebody look at them for half an hour. That just doesn't scale.
Yeah.
Uh, and uh, and so we've had to develop a ton of different techniques that we deploy in order to really quickly make assessments without switching off half the internet. Um,
It's,
uh,
it's a
you
problem.
know, and it's honestly, it's like we'd love to do really fancy stuff, but a lot of the really fancy stuff takes a long time, or it's extremely expensive to do. We can't spend millions of dollars on neural network inference for outbound traffic from a hosting provider. Everything has to be pretty thrifty. I imagine you have some real constraints that you're operating under, and so how have you tackled that particular problem? The problem of like, got to be really accurate, really fast, low false positives, and it's got to run on hosting boxes. Like, how does that all work? How have you tackled that problem?
It's certainly not easy. It's probably one of the more frustrating, cool problems because if you just throw more money at it, you could do so much more. Um, but it does force a lot of innovation. You mentioned like you do a lot of not the most sexy and exciting things that you could possibly want to do. We cannot throw ChatGPT at this problem and say, "Hey, I'm sure you can solve this." I don't know that it could, frankly, but even if it could, we can't do that. It's too slow, costs too much. Da, da, da. So we've had to turn back back in time, really,
Hmm.
and go with the kind of more old school approach for artificial intelligence. Um, Symbolic AI
Hmm.
that's the class of artificial intelligence. It gets a real bad rap. One of the most common things that I've seen is, well, it's just a giant if-else statement. You haven't done anything interesting. If you want to really abstract it way, 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 way out, I can see what they're saying. But it's an expert system and it's fast. These systems really are incredibly quick. And so the expensive part is actually getting the information into the format that the expert system can analyze effectively. And so that's where all of the innovation of like, okay, can we shave off, a microsecond here, to try to get that down? Because that is where the real benefits are. Once we've got it transformed, Symbolic AI is really fast. It's really cheap. It goes through and it does everything it needs. It's also really, really good in terms of iteration. So our system is constantly learning. We have, hundreds of what you would think of as rule updates in any
Hmm.
other AV every day, just constant. Every time somebody or something interacts with the system, it's growing and learning and massaging and improving. But it's the real cheap, real, you know, it's the symbolic AI part that's doing that.
Fascinating.
Trying to transform it into the input, that's much slower, much harder. It takes a lot more, testing, that kind of thing, because it has a big impact. But yeah, so our secret sauce is don't do the expensive AI. That's not a good thing. And invest in transforming the input into
Hmm.
something that can be trivially analyzed by the cheaper AI.
Yeah, that's really interesting that you talk about that. Like not using bleeding edge ML stuff, but using something literally from the '90s. I mean, I studied that in university.
I know,
I'm
right?
older than I look,
Uh,
and I remember writing Lisp programs
oh
to
yeah.
right like to express essentially a symbolic logical system with a bunch of statements, and then it's really cool. It works really well.
Yeah.
Um,
Better than you'd
yeah,
expect, honestly.
right, for this particular problem area.
Yeah.
Yeah, we've used ML models in the past, and we are always developing them. Uh, but I always find it fascinating, when we try something that we think should work really well, and then we find that actually just a stupid classifier, random forest works better. Um, for
I
example,
hate when random forest wins. That
yeah, yeah, yeah,
Ugh.
it's devastating.
It's
Um, but like we were thinking, okay, surely it would be useful to try to characterize and cluster emails based on the subject line's semantic meaning. So you take a sentence encoder, which you can pull off the shelf now. These amazing LLM
yeah,
encoders that fit into a billion parameters.
which is
You can inference them super fast
yeah,
on relatively cheap GPU hardware, and you get this extremely rich embedding that you can use to train a model that will essentially learn that two messages probably came from the same person, even though lots of things about the message might be different.
yeah,
And by contrast, there's another approach is you extract a bunch of analytical features out of the message by looking at the headers and how many MIME parts are there and what order they are and what's the length of things, just like stylometric features
yeah.
that gives you a vector of float numbers, and you jam that into the model. And we actually find that in a lot of situations, the stylometric analysis, which is super cheap and really fast and almost no parameters, outclasses the LLM. Uh,
It's so
it's just
frustrating.
always surprised me when the fancy approach that you think should be incredibly powerful turns out not to beat something much, much simpler. And I mean, working in this area, what one thing that I wish customers could appreciate more is that a lot of our engineering is actually just to kind of keep the wheels on the thing, 24 hours a day.
Yeah. The glue,
right?
ends
Yeah,
up being the
yeah,
and
like
and the scale.
yeah, yeah. How do for us, we need to be able to track the behavior. So first, the first challenge is identifying who sent the message, right? Because the bad guys are, they're using
They don't announce that they're they're the
no.
ones sending it.
We know that the same group is sending out of 1,000 different hosting accounts because
Yeah.
we look at their messages and it's obviously the same campaign. How do you translate that concept into that this is all the same sender? Like that's the fundamental challenge.
Yeah.
But then beyond that, once you know who the sender is, how do you track what they've been doing over time really efficiently so that you can then enforce some kind of policy? Like how do we know that this guy has sent 100 messages in the last 5 minutes? We have to have some kind of counter somewhere, some kind of database that tracks that.
They're centralizing because you're on all
Yeah,
kinds of different endpoints
exactly.
that you want. Yeah, it's
And
a
now,
mess.
and since 2012, pretty much continuously, we have been building and reinventing the same database system and all it does is count events for millions of entities over time and allow us to fetch a variety of counters over different time intervals. But all of those fetches have to be executed in under 1 millisecond. And we're writing 250,000 new data points every second to the database, and we're querying a similar volume every second. And it can't ever go down because everything dies.
I know this
right?
problem intimately.
Yeah.
We have to do SHA lookups. Not because we were necessarily classifying, although if we already know the thing, we probably know if it's good or bad. But we don't want to duplicate work.
No.
There's too much work to be duplicating. That would be insane. And so the very, 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 very earliest part of our process is, do we already know this content? Calculating the SHA is trivial. Looking up, just a simple lookup. So hard. That is the most innovation in our stack is probably around that. Redis actually did a blog post about what we're doing to abuse Bloom filters to be able to do that lookup efficiently and fast. Because once you get past a certain scale, nothing is built to do that kind of stupid, simple thing at enormous scales. You have to custom build them. It's insane.
Yeah, one day I would like to interview somebody who works at a high frequency trading firm because I think that I kind of always imagine that high frequency trading involves a similar kind of analysis. You've got pricing signals pouring in by the millions, and you have to be able to make a decision with a lot of money at stake in milliseconds in order to have any edge.
I feel like maybe that's going to be my next career move because I got a lot of experience solving that problem, and I feel like there might be more money there.
There could be. Yeah, that's the differentiator, right? They do their job right and they make literally billions of dollars.
Yeah.
We do our job right and we just save the rest of the world billions of dollars. The same economic impact, but the money is not flowing in the right direction.
And when we do everything perfectly, if we were literally perfect at our job, people would question why we existed.
Right. I mean, our most common feedback from customers is, "I kind of forgot you exist."
I love to hear that. Minus the business implications. Ignore the business for a second. I love that when that happens.
I think I actually have an idea. MailChannels and Monarchs should announce that we're going to switch off our systems at 4 p.m. next Tuesday for 3 hours.
And it's just like, happens.
Just like inform the New York Times, the Wall Street Journal, and everybody, and we'll just switch it off for 3 hours. It's our customers should appreciate us more. Pre-Black Friday, right? Well, I will give everybody a discount, but just switch it off for 3 hours and see what actually happens. I think it would be an extraordinary impact.
Honestly, it would be a really interesting experiment. A little bit damaging to the
just
the
a little
world about that.
Unethical, yeah.
But that would be a fascinating experiment just to see, get all the rest of the security companies, the enterprise security companies, be like, all right, guys, we're going to drop this for 3 hours. We want you to track deltas, and just have this huge study come in and be like, well, this is objectively the impact that we are having. That'd be cool. It's unfortunately unknowable because we block such a huge amount.
Yeah. Yeah. Speaking about that huge amount, somewhere online, I read that Monarchs ingest 15 billion files a day.
That I will be honest with you. That's not a consistent, constant every day is 15 billion. That's a spike.
Okay.
Um,
But even if it was 1 billion a day, 1 billion a day is 86 million a second, right? Uh, like, where are those being ingested? Are they
s-
ingested on the local machine and then summarized into symbols and then shipped up to the cloud, or do you actually ship the actual
we have to
files?
pull the bytes. We have to pull
Right.
the bytes.
Wow.
So the that creates a horizontal, thankfully, scaling problem. But we we're effectively, it feels like, scraping these, if it's a new file, we're pulling it off of the system in order to analyze it. And so every stage of that process has to be really robust. It can't be going down. It has to be able to handle these insane numbers, and then responsive in the individual lanes as well as just an overall system. Um, that said, we do not have the largest horizontally scalable problem, thankfully. We don't have to innovate on, well, how do you horizontally scale things? We can throw money at one of the large providers and say, hey, you guys had to solve a harder version of this. Let us use your bits and pieces. And so, for example, we don't actually use S3 for this anymore. But
Hmm.
originally, why upload to an endpoint that you're maintaining and controlling and everything? Just upload to a pre-signed URL and let S3 do all of the parallelization nonsense. They're basically never going to go down.
Yeah.
US East. Um, but they're basically never going to go down. And you have no scale problems with that. And then it's just a matter of taking the files that are already in S3 and moving them across the backplane to do. So we cheat a little bit on the scaling since it is a perfectly horizontally scalable problem. We just borrow from the providers that have had to do that. Not that that's easy to cobble together necessarily, but we didn't have to reinvent the wheel. I just had to
Yeah.
learn how to use it effectively.
Well, that's smart not to reinvent the wheel if you can avoid it. And so the symbolic stuff, where does that run? Is that, do you have like a small symbolic expert system running on the box out in the
No,
field?
no. We've thought about that many, 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 many times. The challenge with that isn't so much that it would eat box resources. These things
Hmm.
are very, very inexpensive. The challenge is, would it actually save our entire system money? And the answer turns out to be no, because if the symbolic system on the box makes a decision independent of everything, okay, good, bad, or indifferent, it happened. We have no insight into it, which means we need the thing to report what it's doing to us so we can track it and be like, is this good? Is this bad? Well, how do you evaluate the thing? Well, you would need to sample some of the things that it classifies and pull the file up and look and run it in parallel and all of this rigging and glue and all of that.
Right.
Just upload the file, run it in the centralized place. We'll, we'll analyze it
So
there.
at the end of the day, what you're reporting back to the customer site is this file hash is bad. Block it.
The report is usually or always the file at this location at this time is bad.
Right.
And
Right.
that, for the anti-malware processes,
Yeah.
cron jobs, whatever it is, but files are easy to talk about, easy to understand. The file at this location is bad. And if you flip this on so we do it automatically, we just take care of that for you. Or you can get a list of a million different files and wonder why you're not doing this automatically.
Right. Choice is yours,
Yeah,
the amount of
exactly.
abuse you
I'm
want
good
to
either
take.
way,
Yeah, right. So you've been working on the PHP side at the source in the forest, as you said earlier. We're we're filtering the river coming out of the forest and it's garbage, full of
Yeah.
garbage.
Yeah. Sorry, we can't take
No,
it all.
I know you're doing your best. But what do you see that specifically, like from your viewpoint, how are these guys getting the emails out there through these PHP based platforms? How are they, like, what do they do? What's the actual attack process? Is it similar each time?
I wish. I
Yeah.
wish. The, they innovate. I'm not even going to be subtle about it. They innovate and they're smart. Not all
Hmm.
of them, but enough of them are really smart with their innovations. Um, and a lot of them just lean into bad programmers.
Hmm.
One of the challenges with anti-malware is you have to find something that's malicious, not dumb.
Right.
And it's amazing how close those are when it gets to PHP developers, actually. And so you'll have PHP developers put out a legitimate thing that allows you to send email blanket off of you, what do you want the header? What do you want?
Anything you want.
Exactly, because this person just didn't even comprehend that anyone was going to abuse this. Of course, they, wanted to be able to do this. It's easier for them to have their systems just route to an external to do this. Gravy. I wish that that happened rarely, but the way PHP handles the mail call is tell me what you want to do, boss. And so unless you independently try to limit that in your application, tell me what you want to do, boss. And so unfortunately, a lot of the email spam that comes out of these things, we can't stop.
Right, right, right. I see what you mean. Yeah.
We're the wrong place in the tech stack to stop it because it's using legitimate code paths.
Got it. Got
In
it.
this space, cannot run your entire analytics platform
Yeah.
to determine if the content of that email is good or bad. I have
Hmm.
to say, legit code sending email, go forth and do. And so it's really not a
Interesting.
matter of like, I can't solve the problem you're solving. I can reduce, if they're doing it via a web shell or they got a known bot that's doing this. Yeah, we can remove those. We can clean all that up. But I can't stop the heart of the problem, which is a lot of times I can't tell if it's a good or bad sender. And so I've got to let it happen. And that's rough, especially when you're looking at these things, you're reviewing these things, and you're thinking, wow, this plugin is installed 100,000 different places. It's vulnerable to this 100,000 different places.
Right.
Can't do anything.
But it's like it's a vulnerability, but it's intentionally like that. And
Exactly.
there's probably legitimate applications that are using it that
Built
way, right? Yeah,
exactly.
yeah.
They are built with
Interesting.
the assumption that it's going to work this way. So let's say that we're like, all
Huh.
right, magic, you can patch anything. I can remove the ability for it to be used that way trivially. It's easy. I can submit a patch tomorrow. That gets deployed, and probably 50,000 of those 100,000 installations just break overnight. And so it's a very frustrating place to be,
But so
honestly.
the bad guy, how does the bad guy get onto the box enough that they can use that badly configured plugin to send the mail in the first
It
place?
in this situation, and actually often for email. Email is an interesting case of this. They're not on the box.
Hmm. Literally, they're just using like an HTTP endpoint because that PHP was so bad, it literally allows you to just
Yeah.
send whatever you want.
And
Wow. Got
similarly
it.
on the network, you don't have the time to be able to analyze the
Yeah.
content that's coming
Right.
across. You have to say, okay, good packet, good packet,
Yeah, yeah,
good
yeah.
packet. And the fact that people are sending emails from a network source, it's good most of the time. So you can't shut it down. Like it's just it's why you need defense in depth. Everybody in the security ecosystem knows you need defense in depth. It can sometimes be hard to explain to a layperson or a hosting provider, some of them, that I'm sorry, we literally cannot prevent everything. You need different tools at these different places. And
Yeah.
we're not Palo Alto Networks. We don't have soup to nuts, the entire
Yeah,
stack. You're
yeah.
going to have to mix and match in order to get this done. And yeah, it Email is a fantastic example. The chances of us ever attempting to solve that problem are very slim. It's really complex. It has its own unique challenges and so on. We don't have that expertise. So we would much rather be like, hey guys,
Ah,
why don't you come over
yeah,
here and solve this?
and similarly, the people who work on our ops team who are sort of like looking at the signals, and they can see the 1,000 accounts that are all being used by the same Brazilian spamming gang. And they talk to the provider and like, why can't you stop these guys from coming in? And they're like, we just can't, so now I have a better understanding of why that might be the case. We should definitely exchange data. I think that could be rather useful.
Yeah, I think so. I think so.
Yeah. That'll have to be a follow-up conversation. This has been a really fascinating conversation, Rob Seger. I think we should probably have you on again in the future,
I love that.
and talk more and go into even more technical depth. But I think that this is probably enough for a lot of people so far.
Yeah.
Yeah.
Well, I enjoyed it. I'm glad to hear you did as well.
Yeah, 100%. So Monarchs is well loved by hosting companies everywhere. I've never heard of a hosting provider talk about Monarchs in anything but the most positive terms. So I wish you guys all the continued success in the industry. I wish everybody would use Monarchs across the board. It would definitely make our job 1% easier. Although now that I've heard the reason why the mail slips through, okay, maybe what we should be focused on is PHP developer education.
We could reduce it considerably though, because it's not like web shells aren't used for this.
Right. Of course. Yeah. All right. Got it. Well, thanks, Rob. Thanks for your time and for joining me on the podcast today. And we'll talk again soon.
Looking forward to it.
All the best.